Hi guys, in this video I want to discuss the idea of splitting a function into its even and odd components, and at the end of the video I try to increment your attachment of these guys, cos hyperbolic of x and sine hyperbolic of x with that of an exponential function rather than that of an hyperbola. The reason why I do that is whenever I studied trigonometric hyperbolic functions for the first time, I knew that these guys parameterize a rectangular hyperbola. However, whenever I saw these guys in problems, I just plugged in e power x plus e power minus x upon 2 in place of cos hyperbolic of x and e power x minus e power minus x upon 2 in place of sine hyperbolic of x. So I am more associated of these guys with that of an exponential function. A lot of talking. Let me talk about even and odd functions. Let me give a brief review of them. For more details on even and odd functions, there exists a plethora of resources on the web. Check them out, or else stay tuned to my channel. I will probably do a video soon. Let us suppose if let s of x be a function. If s of x satisfies this condition, s of minus x is equal to s of x, then we call it as an even function. On the other hand, if s of minus x is equal to minus s of x, then we call it as an odd function. This much about even and odd functions is enough for the discussion. Let's start splitting a function. Any given function can be decomposed into its even and odd components. Don't panic. By that what I mean is, you give me any function of your choice, I can write it as an even function plus an odd function. In this case, let us suppose f of x be a function. I can write it as sum of an even function and an odd function. Let me call the even function as f sub e of x and the odd function as f sub o of x. We don't know what these guys are exactly now, but we'll figure them out soon. But it is very natural to think that these guys depend on f of x, right? Let me find what is f of minus x. How do you do that? Wherever you see x in the above equation, just replace it with minus x. So f sub e of minus x plus f sub o of minus x. But because f sub e of x is an even function, by definition of an even function, f sub e of minus x is going to be f sub e of x, and f sub o of minus x is going to be minus f sub o of x, because f sub o of x is an odd function, right? This is going to be f of minus x. Let me call this equation as 1 and let me call this equation as 2. Let me add equation 1 and 2. What are we going to get? F of x plus f of minus x is going to be twice f sub e of x, and plus f sub o of x and minus f sub o of x gets cancelled out. That's all. If I bring this 2 to the other side, we have f sub e of x as f of x plus f of minus x upon 2. Let's find out what is f sub o of x. Let me rewrite these equations 1 and 2 separately, and instead of adding these two equations, let me subtract the below equation from the above. You know, if I subtract, the signs of the below equation get altered. So what we have, f of x minus f of minus x is equals f sub e of x minus f sub e of x cancels out, and we have twice f sub o of x, right? If I take this 2 to the other side, we have f sub o of x as f of x minus f of minus x upon 2. So in short, we have f sub e of x as this expression and f sub o of x as this expression. I encourage you to pause the video now and check whether this is an even function and whether this is an odd function. How do you do that? It's very simple. Go back to the definition and check whether f sub e of minus x is going to be f sub b of x and f sub o of minus x is going to be minus f sub o of x. Indeed, they will satisfy those conditions. So let me take a quick example. Let me take f of x as the famous exponential function. What is f of minus x? Is going to be e raised to power minus x, right? What is the even component f sub e of x? Just plug these guys in this formula. F of x is e power x plus f of minus x is e raised to minus x upon 2, right? What is f sub o of x? That is the odd component of the exponential function. F of x is going to be e power x minus f of minus x is e raised to minus x upon 2. Does these expressions look familiar to you? Yes, you guessed it correct. This is cos hyperbolic of x and this is sin hyperbolic of x. So cos hyperbolic of x and sin hyperbolic of x are the even and odd components of the exponential function. They are directly related to the exponential function. That's it. I am Manas Kalyan. Thank you.